Biomolecules. This lesson belongs to second year, intermediate second year. So now we are going to read. Living systems are made up of various complex biomolecules like carbohydrates, proteins, enzymes, vitamins, nucleic acids, hormones, and lipids, etc. Proteins and carbohydrates are essential constituents of our food. In this chapter, we will discuss structures and functions of some of these biomolecules are discussed. How to take the carbohydrates, optically active polyhydroxyaldehydes and ketones are substances that are hydrolyzed to yield polyhydroxyl uh, hydroxyl hydrates and ketones are called carbohydrates. So optically active polyhydroxyaldehydes and ketones are called carbohydrates. Example glucose and sucrose. Now we are taking the sucrose. Sucrose is a common sugar in homes, lactose sugar present in milk. Carbohydrates are also called saccharides. They are broadly classified into three groups: monosaccharides, disaccharides or oligosaccharides, and polysaccharides. Next we are going to discuss monosaccharides. A carbohydrates that cannot be further hydrolyzed is called monosaccharide. For example, monosaccharides, glucose and fructose. Photosynthesis reaction 6CO2, 6H2O in presence of light and chlorophyll to form the glucose. That formula is C6H12O6 plus 6O2 plus energy. Oligosaccharides anhydrolyzes to give 2 or 2 to 10 monosaccharide units. Example sucrose, maltose, lactose, starch, cellulose and raffinose. Sucrose hydrolyzes to form the alpha D plus glucose plus beta D minus fructose. Maltose can hydrolyze 2 moles of glucose, that is alpha D plus glucose. Lactose can hydrolyze lactose can hydrolyze glucose, and galactose. Glucose and galactose are C4 epimers. So that structure having the same configuration, but at the C4 carbon change in the hydroxy group positions. Starch can hydrolyze n number of alpha D plus glucose is the formation. Cellulose can hydrolyze n beta D glucose formation. Raffinose C18H13O16 raffinose can hydrolyze glucose, fructose, galactose. Polysaccharides anhydrolyzes to give a large number of monosaccharides. Example starch and cellulose. So let us, before going to starch and cellulose, consider as a polysaccharides. You have to remember. Let us take the year. Starch can hydrolyze N alpha D plus glucose and cellulose N beta D glucose. Carbohydrates based on the reducing carbohydrates are classified sugars and non-sugars. Sugars also classified reducing sugar and non-reducing sugars. So here non-sugars considered as a starch, cellulose, polysaccharides. Here reducing sugars. Carbohydrates which reduce the peeling solution and tolerance reagents are called reducing sugars. All monosaccharides are reducing sugars. Example glucose, fructose, mannose. Carbohydrates which does not reduce paling solution and Tollens reagents are called non-reducing sugars. All polysaccharides non-reducing sugars. Monosaccharide, aldose and ketose. Glucose is the aldose, fructose is the ketose. Functional grouping. Preparation methods of glucose. Now we are going to discussion of glucose structure determination from cane sugar. In source is boiled with dilute HCl or H2SO4 in alcoholic solution. Glucose and fructose are obtained in equal amounts. Sucrose can hydrolyze 1 mole of glucose and 1 mole of fructose formation. Commercially, glucose is obtained by the hydrolysis of starch by the boiling with a dilute H2SO4 at 293 kelvins under the pressure. C6H10O5, this is the starch. Hydrolyzed in the presence of acidic medium, that is certain conditions we remember, so to form the glucose. So next we are going to discussion of structure determination of glucose. Glucose molecular formula C6H12O6. Glucose react with hydroxylamine to form the oxamine. Glucose react with hydrogen cyanide to form the cyanohydrin. Glucose react with hydroxylamine and hydrocyanine. Cyanohydrin is the formation. Based on the two reaction indicate the in glucose containing the keto group or C double bond O group or nothing but carbonyl present. Aldehyde or keto group present in that glucose structure. Next one, glucose react with the tolerance and paling test. These tests indicate so out of the carbonyl groups, keto is not present, only aldehyde is present. Next, glucose react with bromine water to form the gluconic acid. This reaction indicates the free CHO group is there. Glucose react with the acetic anhydride to form the pentacetyl glucose. This is reaction indicates that glucose molecule containing the 5 OH groups. Glucose react with the nitric acid to form the saccharic acid. So CH2OH group present is there. Glucose react with the hydrogen iodide plus phosphorus to form the N-hexane. This reaction indicates carbon atoms in open chain is based on the above reactions. So glucose react with hydroxylamine and cyanohydrin. Glucose react with the tollens and failing reagents. Glucose react with bromine water and acetic anhydride, nitric acid and hydrogen iodide and phosphorus. Based on this reaction, glucose structure was determined. That is a chain, open chain structure. All of based on the above reactions, glucose structure was determined. CHO, right up like that. Right side OH. Next left side OH, right side OH, right side OH and CH2O. This is the glucose structure.